Okay, this is lesson 28, triangle congruence with side, angle, side. If you haven't already, make sure that you print the notes so that you can follow along. If you haven't already done that, go ahead and pause this video and have your notes printed so you can fill in the blanks as we go. Okay, so we have already discussed triangle congruence with side, side, side. Now we're learning a new triangle congruence called side, angle, side, SAS. So now we're going to go over some definitions. An included angle is the angle formed by two adjacent sides of a polygon. An included side is the common side of two consecutive angles of a polygon. So you'll notice included angle is an angle, okay, in between two sides. An included side is a side in between two angles. So let me show you what that looks like. If you look over here, you'll see that this is the included angle. You see how it's in between two congruent sides? That is an included angle. And then an included side would be between two angles, which I don't show one here, but let's say we had this and we had this. Then this side would be the included side of those two angles. So whatever's in between. Okay, so like I was saying earlier, and you'll see this in your postulates table, that the new triangle congruence that we're learning is called side, angle, side. And it basically says that if two sides in the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent by the side, angle, side congruence. So this is side, angle, side. Side, angle, side. So these two triangles are congruent by that theorem. Now the directions here say name the congruent triangles. So remember from last time, order matters. So if I list this as triangle BAC, then I must say it's congruent to triangle SRQ. Oops, let me put the triangle symbol. Here's why. If I'm going to start with B and I'm going to go across the side with one tick mark and then across the side with two, because I said B, A, C, then I have to do the exact same thing. Starting with S, I got to go across the side with one tick mark and then across the side with two tick marks. So that's why it's S, R, Q. Order matters. Okay, over here it says find the value of X that makes the triangles congruent. Well, because side, angle, side and side, angle, side would make these two triangles congruent, then I know both of these angles measures are equal to each other. So we're going to set this up as 6x minus 27 is equal to 4x plus 7. Then we're going to subtract 4x from both sides to get 2x on the left. We're going to add 27 to the other side to get 34. We're going to divide by 2 and find that x equals 17. So all I did was set this equal to this and then solve for x. Okay, more two-column proofs like we learned last time. Remember how I was telling you that there's always a given. So they're telling us B is the midpoint of side DE and side AC. So you see this right here? They're telling me that that's directly in the middle of this side and this side. So right off the bat, I know that this is congruent to this since B splits it in half. And this is congruent to this because B splits it in half. Another thing that's been told to us is that angle ABE is a right angle, and it looks like they already marked that with the little box right there, so I don't have to do it. They want us to prove that triangle ABE is congruent to triangle CBD. So they want us to show that this triangle is congruent to this triangle. Now I noticed that we already have the side angle side. If we can prove that this is a right angle as well, then it'll be side angle side. Okay, so you always start with the given. And so basically what I write here is just what's been given. So we're going to write down that B is the midpoint, and you can abbreviate since there's such little space, of DE and AC, and also that angle ABE is a right angle. And again, that was given to me up here. Okay, number 2 says side DB, so let me find it, DB is congruent to BE, and AB is congruent to BC. That's what this says right here. The reason we know that is because of the definition of midpoint. Midpoint means that it bisects it equal into 2 halves. So this is the reason that proves this line right here. Okay, for definition of a right angle that we see given to us as a clue right here, and we're trying to find this, we can look up here and see that angle ABE is 90 degrees. Angle ABE is equal to 90 degrees. Why? Because of definition of a right angle. That's how we can conclude that. Another hint for line 4 is vertical angle theorem. Basically, they want us to say that these 2 angles are congruent to one another because they're vertical to each other. So we're going to say that angle ABE is congruent to angle DBC. And then, last but not least, we can prove that these 2 triangles are congruent due to side angle side, which is what we're learning right now. All right, one more of these 2 column proofs. We're given that B is the midpoint of DC. Remember, midpoint tells us that those 2 sides that split it are congruent because B is smack dab in the middle of these 2 lines together. So I went ahead and drew in my diagram the tick marks right here to show that they are congruent. And then we're also told that segment AB is perpendicular to DC. So this time they didn't draw it in for me, so I'm going to go and put in my right angles. So immediately I can see that I have side angle. If I can prove this side, then I'll have side angle side. Okay, so I have to prove that this side is equal to itself. And then after I do that, I will have side angle side congruence. Okay, so remember, we always start with the given. So all they've done is rewritten this. And the reason, well, right here. It's been given to us. So the reason for number 1 is given. Number 2 says definition of midpoint. And like they told us, segment DB is congruent to segment BC. We know that because of definition of midpoint. Line 3 says angle ABD and angle ABC are right angles. Well, that's definition of perpendicular. And I'm just going to use that abbreviation symbol right there. Okay, this clue is very helpful. All right angles are congruent. That means that if this is a right angle and this is a right angle, well, those 2 angles, ABD, is congruent to ABC. Okay, and like I told y'all earlier, we want to prove that this line AB is congruent to itself. So we're going to say line AB congruent to line AB, and this should sound familiar because you're used to this property by now. It's reflexive. Reflexive means that it's equal to itself. And then, once again, the two triangles are congruent because of side, angle, side. So let me mark this up right here with the double. So, side, angle, side, side, angle, side. That was lesson 28. Moving on to lesson 29. This is not new to you, but it will expand on your knowledge of Pythagorean theorem. A squared plus b squared equals c squared. Now there's something called Pythagorean triples. They're side lengths of a right triangle which are non-zero whole numbers that satisfy the Pythagorean theorem. Basically, it's a Pythagorean triple if and only if it has three beautiful whole numbers. No decimals, no radicals. For example, the most common triples are 3, 4, and 5, and 5, 12, and 13. Meaning if I do 3 squared plus 4 squared, it'll equal 5 squared. It'll be pretty numbers. An easy way to find triples is to multiply one of these two sets, so this one or this one, by a whole number. For example, if I multiplied by 2 right here, I would get 6, 4, and 10. 6, 8, and 10, which is this right here. Okay, so triples are basically very pretty numbers. Let's look at a few examples so that way you can see what I'm talking about. So the directions here say find the unknown length in the triangles below. Do the side lengths form Pythagorean triples? So there's going to be a yes or no question. So I noticed that they give me A and B, right? And they have here C. So I'm going to write 15 squared plus 20 squared equals, in this case, x squared, because that's what they labeled the hypotenuse to be. So I have 15 squared, which is 225, plus 400 equals x squared. Add those together, I get 625 equals x squared. And if I take the square root of both of those, I get a beautiful number of 25. So the answer is yes, it is a triple because it came out beautifully. All right, I would like you to try this one. Now be careful because they gave you the hypotenuse this time and then one of the legs. But pause the video, use the Pythagorean theorem, and see if you get a pretty whole number like this or if you get a decimal or a radical, in which case you'd say no. Okay, let's see how you did. We have x squared plus 24 squared equals 26 squared. So we have x squared plus 576 equals 676. Subtract to the other side, you get 100. Take the square root, x equals a beautiful 10. So we say yes, it is a triple. All right, let me make some room over here. For this question, it says, what is the value of x? Well, we're given a leg, A, we're given another leg, B, and then we're given the hypotenuse, x plus 2. So we are going to write that as 14 squared plus x squared equals x plus 2 squared. Now be very careful when you're solving right here. You can't just do x squared plus 4. You need to spread this out and multiply it times itself. So 14 squared is 196. And now we're going to multiply x plus 2 times x plus 2. You have to expand it out like that. So then we have 196 plus x squared equals x squared plus 2x plus 2x plus 4. When we combine like terms, we're going to get x squared plus 4x plus 4. Notice how beautifully the x squared is going to cancel, because if I subtract x squared on one side and then to the other, they go away. So that works out beautifully. And then we have 196 equals 4x plus 4. We subtract the 4 and get 192 equals 4x. And when we divide by 4, we get 48. All right, moving on to radical expressions when that's not a beautiful number. It's any expression that contains a root, so like a square root. Sometimes it's cubed root. Down here it says find the value of x, give your answer in simplified radical form. So these are not going to be triples. They're not going to be beautiful numbers. But we're going to solve them the same way nonetheless. So here we have 6 squared plus 12 squared equals x squared. 6 times 6 is 36. 12 times 12 is 144. Add those together, we get 180. We have to take the square root of both sides. 180 is not perfect, so we're going to make a factor tree. 18 times 10, 2 times 9, 2 times 5, 3 times 3. So you'll notice that a 3 can come out, a 2 can come out, and a 5 has to stay in. So if I take a 3 and I take a 2, that ends up being 6 on the outside, because 3 times 2 is 6. And then the 5 stays in. We add our units, which is centimeters. And that is our simplified radical form. Okay, pause the video and give this one a try, keeping in mind that they gave you the hypotenuse and a leg, so be careful there. And then when you're finished, come back and see how you did. Okay, so we have 5 squared plus x squared equals 10 squared. 25 plus x squared equals 100. Move the 25 over to get 75. We take the square root of both sides. We notice that it's not simplified. So we have here 5 times 15 is 75. And then 5 times 3. Well, there's a pair of 5, so 5 comes out, but this 3 has to stay in. So our answer is 5 root 3 centimeters. How'd you do? All right, last one's a word problem. And it says, the aspect ratio of a TV screen is the ratio of the width to the height of the image. Find the height and the width of a 42-inch TV screen with an aspect ratio of 4:3 to the nearest tenth, so they want decimals, 1 decimal place, of an inch. The length 42 inches refers to the what? The diagonal distance across the screen. So if we were to draw this screen, they're telling us the diagonal is 42 inches. Okay, anytime you see ratio, you need to put x behind it, meaning this is 4x and this is 3x. It's a ratio, it's not the exact length. Now notice it's Pythagorean theorem because it's a right triangle. So same exact way, 3x squared plus 4x squared, use parentheses, equals 42 squared. So over here, we're going to have 9x squared plus 16x squared equals 1764. So if I combine those like terms, I have 25x squared equals 1764. We divide both sides by 25, And we get, let's see here, 1056. We'll have to double check that on my calculator. But I know when I take the square, 70.56. Couldn't read my own handwriting. 70.56, which comes out to 8.4. Now don't be tempted to circle this because they didn't ask for x, did they? They asked for the dimensions. So we have to plug this back into both of those to find our final answer. Okay, I'll do that in a different color. 4 times 8.4 gives us 33.6 inches, so there's one answer. And then 3 times 8.4 is equal to 25.2 inches. So that's our final answer. Those are the dimensions. Where does it say again? It says find the height and the width. So that's what we've done right here. Okay, that was lesson 29. And then lastly, we have lesson 30. More triangle congruences. So we've learned side, side, side. We've learned side, angle, side. Now we're learning angle, side, angle. That's where you have the included side between two angles. And then also angle, angle, side. So eventually you'll want to copy these postulates in the table so you'll have them. What this one says for angle, side, angle is that if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So you see right here, this is angle, side, angle. Angle, side, angle. So these two triangles are congruent using the angle, side, angle theorem. Over here, we've got angle, angle, side, in which case if two angles and a non-included side of one triangle are congruent to two angles in the corresponding non-including side of another, then the triangles are congruent. So once again, you'll see this diagram. Notice how the sides are over out here. They're not included between the angles. They're on the outside. So here we have angle, 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 side, angle, angle, side. See, one more time. Angle, angle, side, angle, angle, side. So this one up here is angle, side, angle. This one down here is angle, angle, side. Okay. Right here it says, use angle, side, angle congruence to determine the measure of the sides of triangle DEF. I want you to take a second and look at this and see if you can figure out which sides go with which corresponding sides since these two triangles are congruent. All right. Remember how we talked about writing down congruent statements of triangles? Let's do that with this one. Meaning, if we start with the angle that doesn't have any arcs, you see how this one has 1, 2. This one doesn't have any, right? So let's start with 0 and go to 1 and then go to 2 arcs. So we're going to call this triangle BAC. Triangle BAC is congruent to triangle. Remember, order matters. So no arcs, 1 arc, 2 arcs. DEF. Okay. Now, looking at this, I can tell that BA and DE are congruent. So BA and DE. So if this one's 18, then this one's 18. You understand? Now look over here. AC and EF go together. So we have AC and EF. So if AC is 6, then EF is 6. And then obviously the last one is 17. So it says, use angle, side, angle congruence to determine the measure of the sides of triangle DEF. So here we have EF is equal to 6. DE is equal to 18, and DF is equal to 17. Okay, last one. Given that segment DE is congruent to LK, so let's see, DE, LK, find the area of each triangle shown below. All right, so we see here that they're telling us that this is congruent to this. So watch, they've just told us angle, angle, side. Angle, angle, side. So we know that these two are congruent because of angle, angle, side. Therefore, if they're congruent, then I know that these two sides are congruent. So I can set them equal to each other. 4x minus 2 is equal to 3x plus 1. Subtract the 3x, I get x over here. And then bring the 2 over there, and I get 3. Now, we can't box that and move on because they didn't ask us to solve for x, did they? They said to find the area. Okay, well, in order to find area, I need 1/2 base times height, right? And I don't have the base, and I do have the height, right? The height is 6. I need the base. So I need to plug this 3 in right there. So I'm going to do 4 parentheses 3 minus 2. 12 minus 2 is 10. So now I can come over here and do 1/2. Base is 10. Height is 6. And then I can cross reduce that to a 5. And 5 times 6 is 30. 30 units squared. Okay. This is a practice. I want you to pause the video and use your options of side, 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 angle, side, angle, angle, side, and angle, side, angle. So we've learned these 4, and I want you to go through. So for example, if I looked at this one, I notice that this side is congruent to itself. So I have angle, side, angle, angle, side, angle. So the answer to this one is angle, side, angle. Now, over here on this one, they want you to know that vertical angles are congruent with each other. So these two angles are congruent because they're vertical. That tells us that side, angle, side, and side, angle, side congruence. So the answer to this one and then this one. So pause the video, finish this sheet, and then come back and see how you did. And if you missed any, correct them and figure out where you made your mistake. Okay, number 3 is angle, angle, side. Angle, angle, side. Number 4, again with the vertical angles, which means angle, side, angle, angle, side, angle. Number 5, vertical angles, side, angle, side, side, angle, side. Number 6, angle, side, angle, angle, side, angle. How are y'all doing? Last 2. This side is congruent to itself. Side, side, side. You see side, 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 side. Over here we have angle, side, angle, angle, side, angle. Okay, that completes our lesson for today.